Do you want me to close the door?
Sure. All right, so performance hunt, right? Cool.
I think that's it.
I'm somewhat unprepared. I thought Göran was going to do this and I was going to sit somewhere comfortably and look at it. Apparently, that got switched on me a little bit.
I own the boss.
So, I can't be your boss. So here we go. We need to talk, right? Few of you, I met a few of you last year, right? For the developer talks. And I talked a little bit about performance. I think I may have conveyed that I was a little disappointed to some degree.
Why do you keep looking
At least you're aware. So, how's it going? What happened? We talked a lot, and unfortunately I can't run in there and fix your code for you. So I'm assuming that everyone did a stellar job. Yes? Yes, no? Right. So, it should be a lot better, and honestly you guys should be better than me at finding performance issues because you've spent so much time doing it, right? Whereas I haven't at this point. Is this correct? No? Did anyone develop any kind of tools or strategies for finding performance issues? Well, this one. But you were pushed by your bosses, right?
No.
No? Oh, you're genuinely interested.
Self-motivated.
Yes, yes. Perfect. We like that. No, it's a very difficult concept or topic to cover. It's kind of in the realm of PDC. What is it? What is performance? I mean, you can spend your entire life chasing performance, often when there's no need. So when should you? I think last year the conclusion was that everybody knew that they had, because the question I asked was, do you have performance issues? And it was like, the entire room was also. Maybe a little bit. So, I know it was, everybody worked pretty hard on the startup times, right? So that was kind of the entry level of this, because it costs you time, it costs the user's time, it's easy pickings. So now what? Where are you going now? Where are you going from? Anyone? Yes.
I'm having a lot of issues, well not a lot of issues, but performance issues with the models themselves.
Yeah.
So just like using the model app to reduce their triangles seems to be the biggest issue in terms of code. I think I'm not too educated on performance issues yet. So.
Alright. Anyone else?
General standards.
What are you doing? Let's single you out a little bit. It's kind of fun because you're brand new, so you guys aren't really, you shouldn't be struggling with the same issues that some of the others do, since you actually own all of your code, so you can't blame even me much. It's kind of nice. So what are your issues that you typically see? And he works in a different industry, not in the office industry, so maybe there's something here that would overlap.
Yeah, some of them are the same, the model language with
Yeah.
3D files. We have people that are just bringing them in and then not doing anything with them, or not optimizing them. They're just bringing them in, saving them, letting them out. The other big one is snapper performance in general. You know, performance when we're stretching, performance when we're even putting little tiny icons on the conveyor. That's a big one right now that we need to address. I think we actually brought that one up to core.
Okay.
Because it was red 3D versus
Likewise.
yeah. So it's how the performance tracker is looking at it, and so it's the number of 2D lines that we put on. But yeah, those are kind of the key ones right now.
Yeah.
And we're still finding them.
Yeah. Yeah, it's things that showed up in their extension was you placed some sorter or something. It took 2 seconds to build a 2D. At that point, you're actively murdering the system. So those should be fairly easy to find, right? Are you looking for those in any way? I mean, 2 seconds. Hopefully, no one has that because at that point it should be obvious. But at what point do you find that it starts getting slow? So how do you test this? Because that's the point of performance hunting. You can't sit around and hunt for performance. It's a never-ending task, and it's almost futile. You don't know. You need an entry point, right? So I think last year it was internal, but otherwise you don't really want to wait till the users are pissed off. That's a little late in the game. I mean, you should at that point, of course, but so how do you find it? What do you do? What's your test? How do you test your stuff?
Something that takes you off, that takes too long.
Yes, obviously, but so how do you find that?
What do you mean by that?
You get reports from the outside, or you run replicate. What do you do?
Well, for instance, I worked on an optimization because we were having very slow load times for our material lists because we have just massive material lists, especially for batteries. So it takes forever for everything to load up, all thumbnails to be created, etc. So it's just felt very slow. So I guess to pinpoint or play around with it, I started doing something. Couldn't exactly pinpoint it. I was jumping into how material domains are created. You know what was chewing up so much time. Using some of those nifty functions for the time checking out, various times for various functions, and just kind of trying to pinpoint it. Couldn't really find an ultimate source, but I found two different directions that seemed to be taking up about close to half the amount of time, and at about that time I called in some support from Tim, and Tim helped me locate the last little bit that I was missing to zero in on it. It's kind of just diving through and looking at times was the biggest part of it.
Yeah, that's exactly my message today too. Is get your arms dirty, dig into the code. That's what you do. And the second thing I would like to say, which I like that you did, that when you feeling yourself with lying, then contact us and ask for help. I will just dig in a little bit and give you some advice on what's going on. Because maybe it's just purely on our side. It needs to be identified together.
Yeah, I think the when we start speaking on performance, that's why I talk right now instead of going in the code. I think this is kind of an important. You need to think about this a little bit. So, what is good performance? If you can't answer that question, how can you do anything about it? And I think I asked this question last year as well. I was hoping they would have a more definitive answer this year, but I guess not. So that's not good. When you write something, when you work on something in a system, it's very easy to, because you're pressed for time, you throw one snapper out and it feels okay. But you have to be writing really bad code for one snapper to be bad. I mean, it's clearly doable, but after you guys solve that, and I do see why that happens, and it is what it is. But it really, when it comes down to it, is we talked about it before. Your code has no value. It's only the function it performs for the end user. Performance is very much the same, right? Does the software feel good? That's really it. So then, the software itself, if you don't load anything, no extensions, and you don't place anything on a drawing, it feels amazing, right? I mean, it's great. It sits there, doesn't do anything. So unless you do what users do, it's very hard to feel the performance. So again, this user empathy, I don't like that. You should just be a user and have empathy for yourself. That's the key to it. So I'm pretty sure all of you could find a drawing that's somewhat large from your extension, right? It should be doable. Load it.
Yeah, and personally, I have an enormously low threshold for patience. It's almost like zero. That's where my idea comes from, flow. And then look at the designer, someone who can use the software fast, and see if they have to sit and wait for stupid wait times. Anyway.
Then the second part is you're going to realize that you're not going to solve this problem. It takes too long. Because it has no end. So you have to decide what is important. So what is important? If you think about it, if you sat down and someone said, okay, you're gonna get a week, but you need to work on performance. Where would you start? what situations would you start with?
Probably measuring the time it takes to build your extension.
Yeah.
When it starts building extension.
Yeah.
I'll start there.
From a snapper perspective, how long does it take to insert the snapper and move it around?
Yeah.
I had the opportunity to sit down with some designers and just watch them work for about half a day. And that opened my eyes greatly because I'm doing my best to act like a designer every day, use the program as I hope it's going to be used. And then just watching them place like 50 materials in the drawing like slowly, and then like everything's just dying slowly, and you know, everything's falling apart, like your eyes just open up like, why would you do that? Also, we need to fix this.
Yes. And I think that's kind of it. I do agree that all of these things that we said, the first parts, which are, I think the bare minimum, this should just happen. This is not something, I shouldn't ever have to stand here and say this. It shouldn't be necessary. Good programmers are pointless. Good developers are awesome. Good programmers to solve little problems, to solve programming problems. Good developers solve user problems. A huge difference here. So, be a user, absolutely. The first one is placing one object on a drawing for measuring performance is useless. But it's better than not placing it at all, I guess. But it really shouldn't end there. So if, let's say we take work surfaces, connect 8 in a group. It should be, first of all, it should take 0 time, because it should be like this. Done. Right? I do that all the time. I'm an extremely aggressive driver. My finger on the scroll wheel is, I'm in and out. That's how I move around. I don't actually move the view anymore. I scroll out, scroll in on another area. So for me, that way I notice very quickly, if I drop something and I scroll, you expect instant feedback, right? So for me, my limit on dropped is probably in the 30 to 40 milliseconds. If you don't move the view, you can probably get away with 200. So depending on the user or what you do otherwise, it makes a huge difference. So you will not notice this, and typically when you implement your first extensions, the users aren't very good at this. So they will move slowly and it will work fine. It's when they start becoming experts that they start complaining. Because suddenly they start moving faster, they already know what they expect, so they don't wait and look for feedback. So be very aggressive, build large groups. Load drawings would be one that I think right now, I'm gonna just guess, that most of you take quite some time to load drawings. It's just a guess. Some of you might be better than others, but after the startup time of an extension, because you really have to think about it, you're gonna do this for the rest of your life. That's the task. Performance doesn't end. Every time you add code, there's a good chance that you made something a little bit slower. Sometimes it's acceptable, sometimes it's not. But it's a never-ending task. So easiest is to not run around everywhere, try to fix everything, because it's not going to happen over a release cycle. So last year we talked about the startup times, and I think honestly most of you did a stellar job of that. I haven't tested every extension we have, but a few I've tried, it vastly improved. So that's very nice. So then, since everyone seems to listen to me for some weird reason, how about we come up with one for next year? What do you want? Should we do load times? Load times would be one I would assume actually affects users quite a bit. It seems like a fairly big one.
Yeah, there's a lot of general issues, like if your graphics is slow, it's going to affect many other use cases as well. So you fix that, you fix many others as you go. And here a good starting point is to get big drawings from real use cases instead of artificial ones. They're often very delicate.
Also, you typically know what you do, I hope. I mean, for the most part, you know sort of what you change. So let's say that someone had an issue with an isometric view, and they got in and they figured out this is easy. I'll just, in loaded one, I'm just gonna recalculate everything, grab everything from the BSP, hope that I find stuff, recalculate a shit ton of bounds, do all these things, they test it on one thing, and it's great. Replicate it, say, on the real drawing, there'll be plenty of them, and there'll be plenty of others. So the time you have isn't that snapper. It is those 1,000 snappers that are all different. So again, be extremely aggressive with this. So we talked about it earlier a little bit, or we mentioned it. Be impatient with yourself and with us, obviously. But overall, just be really impatient. And so aggregate everything. Don't ever test one thing. A user will have one snapper in the drawing for a split second when they start a new one. After that, everything they do is with many snappers. The normal state is large drawings to some degree. So load times would be fun. Don't do much in load. Honestly, it's so easy to go overboard on that one. I don't have too many examples, but I've seen some fairly interesting ones. One came up as the BSP crashes when we load a drawing. I mean, that's not doable. Why would yours crash? And it was exactly that. So it was found that the BSP didn't actually crash. It was just that the stack was so deep that when it got to the BSP, it happened to crash it. If it crashed anywhere else, any other call would have crashed it too, because the stack was dumb. And then that was due to loaded one on an isometric view.
4 megabytes of calls. I think that's what the stack size is currently.
Pretty amazing. So by removing a few things, that shrunk it down so the BSP no longer crashed, but I'm not sure how well it actually solved the problem, and I never put any timings into it. So that's basically other things. Be very, very conservative with loaded one. Absolutely. It is a dangerous, dangerous place to put things. So if you have to do something, where do you put it otherwise? I mean, it's not like we can just go, oh, the software is slow, let's stop doing stuff. It's not exactly an answer to a performance problem to not perform functions. So where do you put them? Nothing? You guys should love tasks by now.
You can sort of botch stuff into idle tasks.
Yes. Using tasks. How many here use tasks a lot? Göran, come up here.
Hey.
Yes, come and drive. It's your keyboard and your computer. And I've actually never been in version 9, so I'm not sure. The task system, let's talk about the task system a little bit, because it can actually solve some of these issues a little bit. They don't completely solve them. You can't just move crappy code to a task and say you've solved the problem either. It is not the right way to do it. You still have to think it through. But when you fix your code to the point where it does what it has to do, because it just, some things have to happen, now it's time to move it. I've seen some good examples from last year where the startup time of the extension was amazing, but then it ran a 12-second uninterruptible task right after. That's not a great way to solve your startup times. That was later resolved, but it's just one of those where problems don't go away because they end up in a task, of course. So.
No, I mean, Rolf is having sessions on the task and task scheduler, so he can go more into detail, but I mean, we can just go briefly into this. I mean, basically you need to split a big problem up into a small state machine that can do limited amount of work and then return, let the task system continue to work, because you only have a little time slot to work in. And there are a couple of twists here as well, because, you know, the garbage collector might kick in, so maybe you shouldn't even use the complete time slot that you get in that task function. Maybe stop at half and you get better responsiveness in all cases, not just in most cases. What was it? Control Shift F12 or to get the task manager?
Control Shift Delete.
It's a wonderful, yeah.
Control
We have to be a little
Isn't that
different. Yeah, so there is this task manager that you can see here. No, we don't need to test the system.
I decided to move that out of my presentation because it's so small, so you can't see it.
Yeah, you can't really see the text, but it just shows you. This is priority tasks, and you should never be there unless you want something to go on while you're animating. And now your time slot is critical, because we don't want to botch the user while animating. Idle tasks, all these things, there's a lot of compiler background, synchronization, and all sorts of stuff in there that goes on. So you can watch it. It says how many calls it does, how much time it spends on average, etc. So we can get the information out. So you can add your own tasks. The only thing to do is to write the task function like this, And Rolf will explain the parameters when you do it. You see it's idle tasks, all of these are the core tasks in CM core default main message loop. So you can go there and look if you want to see examples. So here I've written some test code, if I remember this right. Like here, save test. So I wanted the test to run at startup, because I restarted, this was my test scenario, and I had to push some buttons. So then I set a task to start, so it comes in after a little delay, and then runs a little test script, which goes through my scenario that I need to test multiple times, and then terminates itself and it's done. So, and then you can also play around with this. You know, if you do interact step, you can quit out of things, and so there's some examples of fun stuff you can do that way when you want to automate something to happen after startup. So that's another use of it. But basically, you write a state machine. You know what that is, right? I'm in a working state. I'm not finished yet, so it's probably a very simple state machine. And it has work to done, so it has a queue of work, sort of things you're going to do, like create material, thumbnails or something. So you try to minimize the amount of work you need to do for each step, so you can return out and you remember the state where you are, so you can continue the next time you get a little time slot. And then keep your time slot on an idea like on a millisecond. But sure, you have to spend 5, 10, do it, but don't pass that, because now we're losing interactivity when we want to get back to the user. When he starts a new animation, we want the fastest possible response. So be aggressive here if you can cut down the times. A millisecond is still like 4 million operations in a 4 gigahertz computer. It's a lot of time. If it absolutely cannot be accomplished this way, you should contact me and we'll discuss setting up a little C++ external process to do processing for you. There is this type of trick you can do as well. But it's now we're getting a little bit more advanced, right? But then you get use of all your cores and everything. We'll see if we add some type of multitasking to CM in the future. It's a very hard subject though, so don't think it's going to solve all problems just because you have multiple threads in there. It's the best way to crash a system that exists.
So load, we'll fix load for next year, right?
How about you go through a couple of critical things in Snapper, because they are, that's where you're going to end up here, right?
Yep.
With bound and build graph and stuff.
Yes. I start on the other end. So I noticed something when much like Göran, I'm a very impatient man. So I build tools all the time. I also throw away tools all the time, which is kind of not so good. What you want to do is you want to go and look in runtime. Has everybody been in runtime? Anyone? You've never been in runtime? Runtime is super sweet. You can build so many cool things from runtime. So if Göran hops over to this runtime.class real quick.
Yeah, you can ask questions. I mean, you have an average object. You say .class, you get the class, and then you can ask if it's abstract. All sorts of things here. Ask for its methods, its finals, its fields. It's a common one that we use. So I don't know. You can run something. Use CM core for f in. I have a class already, snapper.fields. That didn't go well. Well, we can get a snapper from what's it? Main world. Oh, main space, right?
Main space. Start selection of snapper.
Any? Class.
No, then get. Sorry.
Yeah, exactly. We were so happy with that piece of vocabulary. So here's the snappers of that, whatever that was. We didn't look at that. Magnus, by the way, want that to even out for this. So he wants me to add that to the language.
So you can start digging into the actual runtime object. So why would you ever want to do this when you can run and just look at the fields? I don't. It's pointless. But what I will look at for is methods, for instance.
Here's another use. I just say source error fix and then what? Find this error. Oh, sorry. That was kind of stupid.
So oftentimes when if we go to chasing a snapper, what allow attach is called, for instance. If you put a trace in core snap, try snap, for instance, it won't really give you much because it depends on the object, right? And with your massive class structures, it's kind of hard to find exactly where that allow snap is. This is where runtime comes in really handy. Because in that case, you have an object of snapper, you just say .class.method allow snap. It'll give you the method, the last method in its chain to find. I'll borrow that real quick.
Yeah.
So we'll do an example of that. There's the mouse. So.
Can you read?
That's a long Wait. Your control key is not where I'm used to it.
It's in the right place. I told you should get your own keyboard.
I'll get it. Don't worry about it.
Move it to this then.
Yeah.
It's kind of good as well.
I'll adapt. I'll just move my arm up like that, and it kind of works. Not really. So back to this guy. So we have something selected. Yes. Found the control. So we have a scarecrow. Let's toy with a scarecrow. And if I hit the control key, it's caps lock, so it's kind of interesting.
Yeah, there's strangely enough no way to turn that off. Rewiring.
It's surprisingly hard. I'm about to switch to the other one. Okay. So I thought I used to this one here. Here. So it will give me something, and then we can do the same thing as Göran did before.
And just next error.
Next error. I don't think the next error really did it for me. But I will use this quite frequently just to find where I will go. A lot of these should probably be bound into some neat little functions that you could use, be useful. But I use this quite frequently at runtime just to figure out what's going on. It's quite neat actually. At first it's not so obvious, but when you get used to it, it's very handy. So I would say use that one. Everybody knows what microtime is by now, right? Microtime. Yes. MP time. Yes. Emma's happy about that. It is literally the best tool for figuring this out, right? Microtime everything. Trace everything. Microtime everywhere. It's honestly, that's the only thing I do when I chase performance. I just put microtimes everywhere. That's it. And that's what you did for finding the materials, right? The thumbnails. It's just microtime. It's pretty hard to sit here and say, let's go and put some microtime somewhere. But the interesting part of microtime is, what does it mean? What range are we looking for? Like if I say animation twice now, how much time do you have? Do you have an answer? Probably not. Neither do I. And it's fascinating, yes?
Yeah, I don't have a concrete exact value, but at the very least, if you notice something out of the ordinary compared to everything else, then you at least have an idea that it's off the baseline, right?
Correct. you need to find something that you consider healthy to define what's sick. So what happens when you move your stuff around and you click on it and you put your times in and it says 50 milliseconds. You sit there and wait. What's wrong? Anyone? Why is it slow?
Didn't put it in the right spot.
Oh, you did? Yeah, you put the micro time literally on release in the window, so you know you're good. Well, what is slow? Oh, I've been there so many times. What's wrong? So this is where, to really hunt performance, eventually you're going to have to kind of stop being afraid of core. So last year we never really got to this, and this is a feeling I get every now and then when I get asked questions. People kind of stop. As soon as they get to core, they stop looking. And I would say if you really want to solve these problems, you can't stop there. I know core is a little scary. It's a swamp. It's my swamp, but it's a little tricky to get down there. But you kind of have to learn how to find these things. So every now and then people say, well, I traced my get 3D and it really wasn't that slow. Everything's slow anyway. Huh? You might have to dig down a little deeper. So this is where you would have to start actually understanding the system a little bit more. I don't think everyone's going to do this all the time, but there might be times where you need to do this. So again, what happens afterwards? What happens after you drop that snapper? Well, my first guess is honestly, and I think most of you will agree, it's probably your models, right? And that'll be the first one. So you would start by just looking at the 2 seconds of draw graphs, for instance. It is not in that scope of your micro time. It will happen outside of it. So these are system specific, right? Your calculate bound would be one. It should take no time. That is your limit. 0 time.
Yeah.
That is literally the limit.
And caching is not the answer, not caching per snapper anyway. Okay?
It should take 0 time. I never understood why it takes any time, ever. We must have failed a little bit on our education. Local bound isn't actually necessarily exactly your bound. It is a bound that is larger than you. You don't want it to be 100 meters each time because you get other problems with the BSP if you start doing that. But for most part, you kind of know what it is, right? So that's your bound. You don't really have to calculate super advanced bounds. If you really want to do that due to like the bounding box, the selection box, you do that in user local bound, not in local bound, right?
Yeah, exactly.
So this is where understanding the system a little bit better becomes very important. So we'll go back to snappers. What are snappers? What do they produce? What do they have to have? Bound, 2D, 3D. Well, I don't have to, but in your case they will. So bound, 2D, 3D, parts. Parts is an interesting one. How long does a part take? Over there.
Which one? Sorter?
Yeah.
Sorter was taking us, what, 3 seconds?
Yeah. So that is a 3-second lockup for always, like always. So that one should probably be fixed. Now you don't really have to take 3 seconds. I see this every now and then. If you have one that takes a quarter second, it's going to be provoked quite frequently. So your 3D you're aware of very well, right? Your 2D you probably ignore pretty heavily because it's usually not a problem. It could be a worst case, but so those are your 2 ones. Connectors being one. It shouldn't be slow, but I've seen some cases where it is slow. But these are entry points that come from the system very, very often. And it's partly my fault, because we just assumed that these would be instant. So we may call them more often than we would necessarily have.
It's partly my fault because I consider our snappers to be parametric systems, and a parametric object, you know from the parameters already what the bounds can be. It's given, especially when it doesn't have to be precise, right? So, and, I mean, you want to debug it, just wire it up to use local bound and bring up the remover animation. You can watch it. You know, there are other ways, of course, but simple as that.
So we've always had this to some degree, but nowadays when everything's a prop op, it actually changes a few other things that you might not notice. So let's say you do something very interesting in your stretch method, and you ask a lot of questions. Since animations are not prop ops, means that in begin stretch you can do whatever calculations you need to do, push them as anonymous data on the animation. You don't have to recalculate them all the time. So there's a couple of new ways of actually caching data. Has anyone tried doing that? There's one. Ah, look at that. Race. No, but if in these cases you calculate a lot of things a lot of times, it makes a lot of sense to do it once and then store it somewhere, right? And since animations now can take any amount of data, you just drop it on there. It's a super easy way of doing it. And I will touch on this pretty heavily tomorrow, so I'll get back to that a little bit. But it's an easy way in animations to get rid of some of this. CJ for the animations worked a little bit on blacklisting. Basically, in your animation, you tried something and it failed, and you know it's going to fail again. Each mouse move, you continue to evaluate the same thing over and over and over again. So blacklisting is also an option that you could employ yourself at any given time, since you can nowadays put data pretty much wherever you want. You want to be a little bit careful about putting them on snappers because they might be actually streamed, so don't do that too much. But on the animation, you can toss data on there. So that means that you could technically start removing these yourself rather than waiting for us to update whatever animation it is in, Abstract Office or whatever. So don't be afraid of doing those things as well. So these are a little bit more high level. I'm not sure where everyone's at. I'm looking at over there. You guys are super experienced, so for you guys it's more, I don't know, just keep going. It really just boils down to the same thing over and over and over again. You have to run your extension. You'll figure out where you need to get what you need to do. But you can't run your extension as a developer that places two things. It is pointless. You have to load a large drawing and do changes to it. It's the only way you can do it. There's no other way. And then you'll find those. And at the same, I'm almost certain that you guys all have slightly different problems. That's my experience from looking at this. Very few of you have the exact same problems. So it's going to be a little tailored. But, so I will have this question. It's been a year, and performance was very important. How many of you reached out to us to get help? Did you get any help?
Good.
Good. I like that. So that means that you should do it again. Yes. And the rest of you should really do this. And I'm not sure how we're going to do it, but if it's bad enough, if it's something that's really critical, then maybe we should meet up so we can really explain how you actually find these things.
Yeah, co-locate one way or the other.
Yeah.
It's worth it.
Yeah. I'm not too far away. You can come in and see me if you want to go through it. It's doable.
You can come to Sweden anytime.
Yeah. Might be better.
I can just do a short break with my own performance hunting. When I started to look at the system, for an unnamed manufacturer, I just did a loop through all the Sim3D models by doing it for directly recursive. It's a for loop that you can just throw out. It's a one-liner, and find all Sim3Ds, open the Sim3D, and ask if it has a bound. And the answer was like over 2,000 models, no. There were no pre-calculated bound. Then, of course, we went to Model Lab and we made sure you can't even save it without getting it out. It's impossible. It's hard coded, so you can't escape. So that's sort of, so you can just reprocess with the batch converter and get bounds. So you should take a look at this if you haven't. Make sure you have bounds on stuff like chairs, right? So we don't have to calculate them every time we bring them in. Then I just went down to where Magnus already pointed this out for me, that auto normals was running all the time. So auto normals is a routine that goes through and looks at angles between faces, and if it's over a break angle, it injects new vertices, so you will see that as a sharp instead of a smooth surface. So it's kind of expensive, and this was running all over the place, and it was it happened late in the graphics pipeline as well. So as soon as you change the graphics, it ran again. So it was like totally horrific. We killed that. So we re-implemented a super fast version that does not do that. It just puts in a normal, so the system, because OpenGL has to have normal. We can't just give it the mesh. It will not show anything or it will crash. But we did a super fast version of it. We moved it to C++. This is in X5 now. So even if you do that mistake and autonomous gets called, it's just going to get sort of ugly or overly smooth. So if you have sharp edges, they're going to disappear and be smooth. So you're probably going to see that visually. But anyway, I mean that time can't really kill the system anymore. But that's the one way you can also do. Go down in CM geometry, try mesh F into autonormals, put in a trace and see if it runs or not. Because it's not supposed to run unless you import something from AutoCAD or SketchUp. That's it. You know. Otherwise, it should not run.
I do remember that one. It was a beautiful, beautiful snapper, amazingly looking. It took 3 milliseconds to do build 3D, and it took 120 to run autonormals. Yeah. So from every possible tool we had that reports these things, everything was fine. Like everything said great, and still it was horrible. Yeah. So I mean, I can't fault anyone for that one. It was we really did a piss poor design on that one. But it's plugged now, so that's better at least.
Just one more thing on this.
No, absolutely.
I had a couple of summer interns in, and so I put them to do, if it hasn't moved away, the graphics debug dialog. Yes, there you go. So you have a number of options here to show. I haven't played with this. You can show vertices indices if you want. Show normals. You get an idea for mesh density here. If you bring that out, you can also, I think. Isn't that, oh yeah, it's on the side, I think. So, I don't think this has an, or if it's bugging right now, I don't know. But it's supposed to throw out, you know, so you don't have to play with zooming in and out to see this. It gives you all the levels of details. That's what it's supposed to do anyway. But this is just a tool like anything else. You don't need to report a bug. You can go and fix it or adapt it to what you want. Yeah.
What dialog is that?
It's called Graphics Debug Dialog. It's in here. So that's a thing with, because if you just look at a piece of graphics like a teapot, you have no idea what the mesh density is. You bring that up and you enable hidden lines or normals, and suddenly, oh, it's very dense. You know? And it also reports stuff in numbers, so you can read the numbers here for the different levels of detail. So it's not so hidden anymore. You don't even need to go to the model lab to play around with it. So this is another example of a tool you can do to dig around with these things. Yeah, beautiful, huh? So that's a bunch of normals. Yeah, but that's actually the data that we're looking at. So if you have one of these million polygon models, it's going to be kind of dense and it might slow to a crash as well if you enable it, especially if you do the vertex indices. Enable vertex indices, please. There's a checkbox there in the middle. Somewhere. Wasn't it? You can't see on the big screen. Oh, yeah, you did. The numbers are all over the place. Yeah, fine. Cool. But it did work. That's fine. Anytime I start to work on something, I just adapt the tool. I mean, the tool is there, you can look at it, you can make a copy of the whole thing if you're not happy with it and bring it up to your own extension, or you can just keep adding to it and then suggest the changes to us. And we'll see if we like them, we incorporate them and provide them out. it's the whole idea, you know, we thought when we started out the CT project, why don't we more or less open source the whole thing? There's almost nothing hidden. The compiler is hidden, and there's some crypto stuff going for license management. And the rest is open for you to read, and then you should be able to contribute as well, right?
Yes, so that's the next question. What tools are you lacking? Because it's sort of like show hunting techniques. The answer is literally just microtime. That's the only thing I do. That is my entire toolkit. Every now and then I will especially write a tool, but otherwise it's literally microtime. And of course I kind of figured out where to put it. So rather than just throwing it around your animation tri-snap, I might go a little bit further out. So I will actually put in the animation so I can capture all of them. So otherwise you don't get a clear picture. So again, go down to core a little bit. But other than that, it's literally just, I use microtime. That is it. That's my entire toolkit. As sad as it sounds. And it's that simple, yes.
And the scroll wheel, right?
Yes.
Because the scroll wheel, you will see how long time it takes for the frame to draw. So by starting to scroll as soon as you've done the operation, is there a delay before it starts to zoom or not? That's typical Magnus style.
Yes, so microtime is how I find something. Why I start is because I use it. So yes, again, you have to use your stuff to know if you need to start. After that, it's just microtime. You only have, I mean, at this point, if you did anything last year, you should, that's what I'm saying, you should probably be better than me at this point, maybe have better tools. But that's literally it. If I move around, it's all capsulated in one spot, you microtime it, you test it against some other object you have that doesn't feel like crap, and you see the difference. Oh, it is in fact 60% more time spent on this. Then you microtime down until you find it. One of the things though I noticed is there seems to be overall some confusion on how to change animations. And lately, I can't speak against any of you guys, but I started seeing some very interesting code in you know, allow attach, for instance, for changing behavior in animation. These are extremely dangerous. First of all, that one is a bug. And I saw it very recently. If you do allow attach and you say yes or no depending on what animation is running, it is a bug. Now it will change the behavior of the animation, absolutely. It will also have a lot of interesting side effects, and it becomes very unclear when it's going to connect or not. It will connect differently depending on what you're doing. It's extremely dangerous. But this is also where I find that the hardest performance things I looked up are exactly that. Someone done something in an innocent little function, allow attach, for instance, where they decided to, not fully understanding that that is not what's run when you snap, when you action connect. It's being run all the time. These should also be very, very quick questions. So this is where we're going to have to work on this a little bit on updating our material on when our system assumed that you were crazy fast and you don't understand that, I guess. So we may not have been entirely clear on that. Those are very, very hard to find. But again, it is just p-time, it's microtime. It's not crazy difficult. The problem, of course, you're going to run into, so if you wanted to have any kind of technique, it would be that if I start in between these two points, everything happened. Microtime. Okay, it took 60 milliseconds. Now what? And then you check this part and this part. That's 30. That's 30. And then you start going down. It becomes very hard to pinpoint it. It's sort of like a profile in that sense that it doesn't really tell you much. You keep searching and then the time kind of disappears on you. And because it's actually the complexity in itself that's the problem rather than how much time each little piece takes. Right? These are, I agree, very difficult to solve, and there's no simple solution to this because the answer is you have to get rid of that complexity. Now there's no technique for that. You just have to rewrite it and not do that.
Yeah, and that's why profiling almost always, in my experience, totally fails to help you. Because it does not make you understand the code anyway, it just pinpoints nothing. Everything is just one big slope, when the biggest one is 7%, and everything is
the thousands of functions down on 1%. So where are you going to go?
Well, it can't be thousands on 1%, but yeah, I see what you say. Could be 100.
I have one instance of profiling where it really helped us. It wasn't even done by me, but someone in the compiler team did it. We discovered that the member test of the C++ compiler was done for the most general case of multiple inheritance, and that involves string compare. So we were spending 10% of compilation time to start up CET in string compare. This is hidden so deeply below the surface, and I just assumed, because I implemented the compiler myself, they are highly efficient with it. It's a 2-array lookup to do a membership test in a single inheritance system. So I just assumed they did that. I couldn't even imagine I had to go and optimize that for it. The C++ is a low-level thing, and suddenly they decided to do a high-level thing for a low-level operation. It's ridiculous, you know. So sometimes something happens below the surface, and you can use a profiler to find out. And then just so you know what we did? We implemented our own membership test and the whole algorithm in just a few inline methods instead of, so we got rid of that.
I think it could be useful if someone's done something really stupid. So I tried a profiler in calculation for some customer, and I didn't know anything about their code, I didn't know anything. So I just loaded it, I pressed refreshing calculation, I ran the profiler, I started profiler, then I hit refresh, and then I stopped it, and then I had a look. And I could quite quickly see what kind of parts that took a long time to calculate.
Yeah.
And then I started tracing the code. So sometimes it could just give you a way to start.
Yeah,
Because otherwise,
when it's like totally quadratic algorithm that's just destroy and murder the system, you will find that. Yes.
Yeah. No, if you have one misbehaving function, it works great. I agree, but a lot of times when you talk about the snapping behavior, for instance, it's a gazillion functions that all take no time.
But the other thing we've been working on, core 2, right, is these permanent profiling points is what I would call them. That means you use microtime where you know there is some type of threshold that you can estimate. So, I mean, flush for the view shouldn't be over this or that value. If it does, print out a warning. Or you can enable them. I want to see all these critical times at different places. So then you can have one of these permanent profiles in get parts and with a threshold. So then it doesn't span all the time. You only for when the parts are separated. So this gives us, so I mean, we should together be able to identify all of these critical or at least normal points where you shouldn't spend all that time. And that sort of becomes a living documentation instead of a dead documentation that falls out of date besides, right? But then you can go in and look at the thresholds and they actually tell you what the reasonable value is.
So, until next time, you will run your software, right? And you will try, and you will call when you fail. And load times are going to be amazing. So the question will of course now be, how much faster is your load time or startup time? Hayward, numbers. No, but if you gave it, I mean, I don't need numbers, but like percentages. Well, is it twice as fast, or is it 10 times as fast? Is it amazing compared to before? Let's give it a slightly better to amazing scale instead of numbers.
It's probably over double. We moved a lot of stuff, twice as fast. We moved a lot of stuff into idle tasks that we were kind of just doing upload.
Fantastic.
Beautiful. How long did it take to make those changes?
A couple days.
Okay.
So how long do you think, from management point of view, does it take for you to earn that back? You restart, I mean, because we have the incremental system, we don't restart all the time, but we do quite a lot anyway, for different reasons. Time gets eaten, right?
So it can be a good thing to remember these times, because they will start creeping back on you eventually, I'm sure. So remember where you were, where you came back to, and then when you back up on the high number, we can start working our way down again.
And you gotta consider everybody's time too. If you have multiple developers,
Yeah.
Hayward, we have, how many at this point? It's getting ridiculous. It's 5 or 6.
Yeah.
So you multiply that by the 5 or 6 developers, and that's save time.
And then when you call Magnus because you need help, he has to sit and wait for that time instead of working on your problem. So it's not productive. It's simple as that.
Yeah.
I'm just allergic to waiting times because it's a waste of our lives.
Because we are talking about loading time, and I think about drawing load time. So depending on different development teams, for the new development teams, it might be a learning curve where they end up having quite much loading code before they get to a stable level where it's no more important. So we may end up in a scenario where we want to say, hey, there's a lot of load code and we want to get rid of it. So we may need to implement some batch processing that, hey, you get this for this release, you process all your drawings, and in future we will remove our load code. So is there any, because there are, for testing, there is a core interface which you can build upon. So for this type of scenario, any core infrastructure is there?
You write the for loop, you load the drawing by
I know.
and then you measure time with micro time. It's a 4-line.
Yeah. No, client may expect a nice interface, something like that, and to develop how to say, a unique behavior across the vendors. If you have anything like that.
So you would like to basically run CT Designer without seeing CT Designer, more or less, if I get you correctly.
So what I'm thinking is, in CET, end user gets an interface which we can evolve based on our thing, or it can be a purely core that, hey, you go to this, browse to your folder where all the drawings are there, and upgrade. So upgrade, because a lot of technologies where evolution happens, they do provide it that we will stop the backward compatibility from next year.
Yeah.
Please migrate your files.
Yeah. Right now we don't have anything like that. In your case, I would probably suggest making one dialogue with one button and a nice text that says, go have dinner, come back eventually, because that's what you're looking at, right? Or you make it nice and it takes one drawing at a time. If you do this though, when you do load drawings, I would suggest that rather than loading them and actually loading them into CET as a visible world, because that would provoke building 2D, 3D, everything else, which we don't want at that point, most likely. You would like to do a silent load of that. Can we do that, Emma? I think we can. But we might have to do a little function that just does that and doesn't set main world, because that's pretty much it.
I mean, we don't have it, but we can, of course, plan with it.
Yeah. Because I agree. I've actually thought the same thing several times. That we. What?
If you don't flush, I don't think you will build anything.
I wouldn't bet money on that, but yeah. Shouldn't and won't are two different things, but we can try. No, I like where you're going with that. It's an interesting idea. The question is how long it will take, of course. If it takes 14 days because you have massive servers, then you don't want to do that on your user machine, right? So you want to start that on a separate machine. But absolutely, I agree. There's sometimes that could be definitely be useful, but I mean, one has to understand that it could be a very time-consuming process. So if you come in on Monday, if you come in on Monday and you're an end user, you don't want to get a dialogue that says go home. Right? That's not really acceptable. So then the question, if it's voluntary, when it's going to happen, and when do we then remove the code? Because there needs to be some sync between these. You can't just remove all the load code and not have transfer the drawings. So you need to synchronize that in some fashion eventually. What about the users that didn't click OK ever? What happens to their drawings, etc.? So there's a little bit of a process, I think.
As my co-worker said, the version numbers for load code, like generally quick check to see active version less than whatever, so that way it's only running on the old drawings, basically. That's one tiny little optimization that should actually, in my opinion, be everywhere in terms of when you're dealing with old, converted old drawings.
It's something or quite often is the document check version.
Okay. Do you think it's slow to check with the current method and load?
No, it's that they run it always, regardless of the version.
Yes.
So they run too much code.
You should add the version check to your load code.
Yeah,
If you're
that's
not running
right,
it, it doesn't mean
That's
you're
what, that's what package versions is for.
Yeah, that's what
why I added
it's
it.
for.
That's what it's saying, use it.
Yeah.
Yeah. Fine.
Yeah,
No, I don't think